Dear friend, welcome to the lecture series in electromagnetic fields and waves. Today's topic is skin depth or depth of penetration under the title of electromagnetic wave characteristics. In this video lecture, we will be able to learn to derive the expression for the skin depth or depth of penetration, which is equal to 1 by alpha in meters, and also we will be looking at a numerical problem based on the formula. Coming to skin depth or depth of penetration, when an EM wave is propagating through a conducting medium, it is attenuated. The attenuation constant is given by square root of omega mu sigma over 2 in Napier per meter. As frequency omega increases, the rate of attenuation increases, that we can see in the expression. The wave penetrates only a very small depth before it attenuates to a negligible value. The depth of penetration is defined as the distance at which the wave attenuates to 1 over E or 36.8% of its initial amplitude. It is also defined as the reciprocal of the attenuation constant alpha, so that we can write delta equal to 1 by alpha in meters. Coming to the proof, consider an electromagnetic wave propagating in positive z direction. We know that the amplitude of the electric field vector attenuates exponentially with the attenuation constant alpha, so that we can write E equal to E naught e power minus alpha z, where E naught is the maximum amplitude. At a depth equal to z equal to delta, E attenuates to 1 over E. Therefore, we can write E equal to E naught over E, which is equal to E naught e power minus alpha delta. Equating these two terms, we get 1 over E equal to e power minus alpha delta, and we can write 1 over E as e power minus 1, which is equal to e power minus alpha delta, so that minus 1 equal to minus of alpha delta we can write. Now delta becomes 1 by alpha in meters. We have various mediums, and for those mediums we are writing the expression of the skin depth. As we know that the skin depth expression is delta equal to 1 by alpha. Now for the lossy medium, we are writing the alpha expression in the denominator, so that the delta expression is given as like this. And for good conductors, delta equal to 1 by alpha, so that it is equal to square root of 2 over omega mu sigma. For good dielectrics, delta equal to 1 by alpha, which is equal to 2 over sigma square root of epsilon over mu. For perfect conductors, sigma is infinity, that is conductivity is infinity, and the skin depth becomes delta equal to 0. For lossless dielectrics, the attenuation constant is 0 and the skin depth delta equal to infinity. Now looking at a problem, here the problem says find the skin depth at a frequency of 1.6 megahertz in aluminium, where the conductivity sigma equal to 38.2 mega Siemens per meter and the relative permeability is mu r, which is equal to 1. Also find the propagation constant and wave velocity in the medium. Coming to the solution, let us write the given data first. The given data contains the frequency, that is 1.6 megahertz, which is written as 1.6 into 10 power 6 hertz, and the conductivity of the aluminium material is given, that is 38.2 mega Siemens per meter, so that we can write 38.2 into 10 power 6 Siemens per meter. Now the relative permeability is given, that is 1. To be found is, we have to calculate what is the skin depth for the given material and the propagation constant and the wave velocity. Now we will be looking at what are the formulas to be used to calculate those parameter values for the given problem. In order to use the formulas, appropriate formulas, first we have to calculate omega epsilon, so that it makes us to use proper formula. So omega epsilon is written as 2 pi f epsilon, And here epsilon can also be written as epsilon naught, epsilon r, so that 2 pi into 1.6 into 10 power 6 into 8.854 into 10 power minus 12 into 1, which gives us 611.6 into 10 power minus 6. By looking at this particular value, we conclude that sigma is very greater than omega epsilon, as sigma value is already provided to us, so that the given medium or material is a conductor. Now the formulas that are governing the conducting medium we have to write. So for good conductors, the skin depth is given by 1 by alpha, which is equal to square root of 2 over omega mu sigma. And the propagation constant that we can write is gamma equal to alpha plus j beta per meter. And the wave velocity Vp equal to omega by beta meter per second. Now we go for the calculation part. The first one, we have taken the delta, so which is equal to square root of 2 over omega mu sigma, and here omega is the angular frequency, which can be written as 2 pi f, and mu can be written as mu naught, mu r, and sigma will be taken as it is. Now we just substituted the values for the above expression, then we get the skin depth as 64.37 micrometer. Now coming to the second part, that is propagation constant, which is equal to alpha plus j beta per meter. And we know that for good conductors, the attenuation constant and the phase shift constants both are equal, and there is a relationship between the attenuation constant as well as the skin depth, as they are inverse to each other, so that if we have the value for delta, so that we can easily calculate the value for alpha and beta. So here we are taking as 1 by delta, which is equal to 1 over 64.37 into 10 power minus 6, so that we get 15.533 into 10 power 3. Now here substituting the values of alpha and beta in the propagation constant gamma, so that we can get 15.533 plus j 15.533 into 10 power 3 per meter. Coming to the wave velocity, which is given by omega by beta, and we know already omega is the angular frequency, can be written as 2 pi f, and substituting the values for the corresponding parameters in the expression, we get the value of 648 meter per second. Now the final part is result. So the skin depth is obtained as 64.37 micrometer, and the propagation constant is 15.533 plus j 15.533 into 10 power 3 per meter, and the wave velocity is 648 meter per second. Hope you like this video. Do subscribe my channel and click the bell icon, so that you will be notified with the latest videos. Thanks for watching.